Hi everyone. Today's lesson goes along with guided notes number 2 from unit 1.2 on transformations. Now, today's lesson is all about something called a translation. A translation is a transformation that glides all points of the plane the same distance in the same direction. A translation is an isometry because distances are preserved. Remember that an isometry is where the pre-image and the image are congruent. So say you're working with a triangle. So if you started with a triangle as your pre-image, and then you translated it 2 units to the right and 3 units down, the new triangle that you create is going to be congruent to the original triangle. For each translation, a rule can be written in the form T, the capital T stands for translation, and then we take every point x, y, and map it to a new point by doing x plus a and y plus b. And what we need in between here is just a little arrow to indicate that this is a mapping. Okay, in our first example, it says graph quadrilateral ABCD with the following vertices. A is at -2, 1, B is at -2, 4, C is at the point 3, 6, D is at 3, 1. It says find the image of each vertex with a translation x, y, mapping it onto x plus 3, y minus 2. So that means that we want to add 3 to every x value and subtract 2 from every y value. In terms of the graph, that means we want to map every point by going to the right 3 and down 2. Because x plus 3 would push you to the right 3 units on the x-axis, and y minus 2, you move down 2 units on the y-axis. Alright, so if we take our first point, point A at -2, 1, and you can either do this algebraically by adding 3 to the x value and saying -2 plus 3 is 1, and then subtracting 2 from the y value, 1 minus 2 is -1, or you can use the counting method. So I'm going to change colors here on the graph. I start with point A, put my pencil point on point A, and I want to go to the right 3 because it says x plus 3. So right 1, 2, 3, and then down 2 because it says y minus 2. And that's where my new point, which will be A prime, will be located. And notice that its coordinates are 1, -1, and that's what we got right up here. So do that with all 3 of the remaining points. So with point B, start with your pencil point on point B, go to the right 3, 1, 2, 3, down 2, and then B prime should be at 1, 2. Alright, so check that out. Right 3, I did x plus 3, so -2 plus 3 is 1. And then for the y value, I subtracted 2 according to this rule. So 4 minus 2 gives me 2. So that checks out. Don't forget the prime notation on each of your new points. For point C, again, we're going to start at the point 3, 6. So pencil point on 3, 6. Go to the right 3. 1, 2, 3. Down 2. 1, 2. That's where C prime will be located. And its coordinates are 6, 4. Again, add 3 to x, subtract 2 from y. And then finally, point D. Put your pencil point on point D, and then go to the right 3. 1, 2, 3. Down 2. And that's where D prime should be. And its coordinates are 6, -1. So you can see I added 3 to the x value, subtracted 2 from the y value. Alright, take a second and sketch a new figure by connecting your points. So B prime, again, was at 1, 2. So connect that point to C prime. And you guys should be using a ruler to do this. I just can't use a ruler on the iPad. And there's our new figure. And remember, we call this new figure the image. The original was called the pre-image, and you can see that they are congruent. They're the same size and shape. Okay, in our second example, we have a little bit of practice with writing the rule of the translation of triangle ABC to triangle A prime, B prime, C prime. So it's important when you're writing the rule that you start with A and you go to A prime. Okay, so we don't want to do it backwards and start at A prime and go back to A. So if we're just writing the rule, we want to ask ourselves, are we moving left or right for the x value? And we are moving to the right 3. So that would give us x plus 3 as the first part of our rule. And then from that point, we're moving up to 1, 2. So that would be y plus 2. So the rule would, if we wanted to write it out completely, we'd say xy, every point xy maps onto a new point by doing x plus 3 and y plus 2. Now you really should do a check. Make sure that rule holds for all points in your picture. So go to B and go to the right 3, 1, 2, 3, up 2. We got it. Go to C, right 3, 1, 2, 3, up 2. And we ended up at C prime, so our rule is correct. All right, in our next example, it says, given the image and a rule for the translation, find the pre-image. Okay, recall that the image is the output or the result of a transformation. The pre-image is the input. So this is an example where we want to work backwards. According to the rule, all these points were translated into these new points by going to the right 4. That's x plus 4, and up 4, because that's y plus 4. So we want to work backwards. To undo this, so that means we're going to take each of these points and go to the left 4 and down 4. So you're undoing what has been done. So if we start with point E, put your pencil point there, go to the left 4, 1, 2, 3, 4, and then down 4, 1, 2, 3, 4. So I'm going to make this point a little bit more noticeable and put just a capital E next to it. And point E has coordinates -3, -1. And then we can check it out with the rule. If I do x plus 4, -3 plus 4 does give me 1, so that checks out. And check out the y's. I have to do y plus 4. So my y value is -1 plus 4. That gives me 3. Okay, so you want to follow this pattern for all of your other points. So next go to point K and go to the left 4. 1, 2, 3, 4. And down 4. 1, 2, 3, 4. So point K will have coordinates -1, -4. All right, keep going. Point Z is right here. We want to go to the left 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. So point Z has coordinates +1 and -4. And finally point G in this upper right, G prime in the upper right hand corner. To find the original point G, again go to the left 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. So point G has coordinates 1, 0. And again, you can check them all by applying the rule at the top of the page, the top of the slide, and confirming that your counting worked. Finally, connect your dots to form your new figure, and it should look congruent to the original. Okay, so my line over here is just slightly off here. All right, you guys, when you're working on your homework, you should be working with a ruler. I can't do that on this, but it'll make your graphs a lot neater. Okay, in our next example, it says find and graph the coordinates of the pre-image of the figure below. So remember, pre-image, if we're asked to find the pre-image, we're working backwards, so we need to undo this rule. This rule says x plus 2, y plus 1, so that would indicate that they were moved to the right 2, up 1. We need to work backwards, so we need to go left 2 and down 1 for each of these points to find the pre-image coordinates. So I'm going to start with point N prime here at the top. So we want to go to the left 2, so left 2, down 1. So there's point N, and it has coordinates -3, +4. Okay, next go to point D. So put your pen or your pencil on point D prime, and we want to go to the left 2, 1, 2, down 1. So that's where D is, and D would have coordinates of -4, +2. All right, go ahead and connect those 2 points before this becomes too confusing. All right, next go to point P prime, and we want to go to the left 2 and down 1. So pencil point on P prime, left 2, down 1, there's P, and it has coordinates of 1, 2. And finally connect all of your dots to make your new triangle. And again, it should appear to be congruent because this is an isometry. Okay, in our last example, it says graph the following figure and its image. So the original points are Q at 0, 0, and R at 3, 2, and point S at -4, +3. So if you connect those points, then we create a triangle. Okay, so the image would be the result of the transformation according to this rule. So you can do it 2 different ways. You can plug your points in, like I can plug in 0 for my x value and do 0 - 4, and 0 for the y value and do 0 + 2, and that would give me -4, +2. So that's doing it algebraically using the rule, or you can follow the rule by using counting on the graph. So x - 4 would indicate we want to go to the left 4, y + 2 we want to go up 2. So let's see if our point -4, 2 is correct. So come to point Q, and we want to go to the left 4, 1, 2, 3, 4, then up 2, 1, 2, and there we are. Q prime is at -4, +2. Okay, so it's your choice whether you do it algebraically by plugging the x and the y value into the rule. So in this case, for point R prime, we would take and plug 3 in for x, because remember the x coordinate always comes first. So 3 - 4 is -1, 2 + 2 gives me 4. So let's see if it holds true on the graph. So go to point R, and we want to go to the left 4, 1, 2, 3, 4, and up 2. So point R prime would be at -1, +4, so that checks out. Finally, with our last point, S is at -4, 3, so we want to do -4 - 4, and then we want to take 3 + 2. -4 - 4 is -8, 3 + 2 is 5. So let's do one last check. Start at point S, and we want to go to the left 4, and then up 2. And this one's going to go off the graph just slightly. So left 4, 1, 2, 3, 4, and then up 2. Okay, so S prime would be there. And it has coordinates -8 and +5. Sometimes it's hard to tell when we're making practice problems exactly where they're going to go. Okay? So connect your dots to make your pre-image and your image, and you should see that they are 2 congruent triangles. All right, next up, try the check your understanding problems and ask if you have any questions.